Welcome to Baba Boss channel, and this video will talk about in detail enterprise scale recommendation engine. Enterprise scale meaning here how the big retailers, big e-commerce platform recommending products, items, or how they are recommend the marketing content to the user. All thing we'll talk about in this video. Mostly I will go complete flow, complete pipeline, how they build end-to-end enterprise scale recommendation engine from user journey to content delivery journey. Everything I will talk about in this video. Okay, so briefly I will explain the pipeline and flow, how content generation, how recommendation engine will work here. For example, you just imagine that you are on Amazon.inia.com, you are shopping on that, and you are clicking any product. Whenever you click any product, so it will show the product journey. When you are adding to in the wish list, you are adding to it in a cart, or yeah, you are searching with the keyword particular product. For example, you want to product a RoboCar toy. Yeah, any toy, you are still searching at that on search criteria. You're just writing a descriptions. Okay, I want this kind of learning toys, all things. Then that recommendation engine start working on that. It will take all the parameters. There are offline and online. Both are pipeline is there. But whenever any event created by the users, then first like event is created, event go to any like technical like Kafka or whatever, and for future purpose that's all the features stored for offline feature store, and another will go for real-time feature store for further processing. The getting all the informations, it will generate the candidate generator. It means like it will generate the item for particular user. It will give the list of item, the probable list of item, like 100,000, not fixed, but based on the candidate generator. The many candidate generator can used, and a combination of the candidate generator use, like collaborative filter, content based, a trend, yeah, popularity based, many more like content generators. That will go detail about the candidate generation in this video. Just keep in the video, I will talk about everything and how you can create your enterprise scale recommendation engine. Output of this content generation, for example, 1,000 items listed for that user, but user, we can show user like whenever you are on particular retail page, your app, then you will see there only top 5 or 10 list of product for you. How out of that 500 or 1,000 item list, that is built by ranking model, and ranking model can be machine learning, classical machine learning based like XGBoost, or yeah, deep learning models. It can be transformer, yeah, attention based model also. Finally, it will give you the content also. Plus, can it's give you personalized feed also, suggest content also. Like it will create a personalized video for also. Like that is the I think this is the completely new features that I will talk about. I think most of the industry they are working on personalized content generation using generative AIs. They will suggest, they will not directly suggest you. I think in recommendation engine, just keeping stop here. In recommendation engine, like two type of recommendation engine for user and recommendation user. engine for content marketing. Anyway, both recommendation apply for the user itself, for user, but the task is different. First one, recommendation engine you use for recommend the products, items. Second is recommendation engine give content, relevant content for marketing to attract user to buy particular product. The recommendation engine that know what user have emotions, what user want, and it will show off journey of happiness. It will create image, video using AI. It will show the content. So that is very and interesting and fantastic things, and lot of retailers they are doing now. I will talk now step by step. First, like okay, event generated, event go to the Kafka and then go to feature store. We'll go one by one. So we'll go first event generator. Okay. So what are event collector? Where whenever user come to the any e-commerce platforms, then start collecting the information like product views, clicks, add cards, purchase history, how much time spent for particular item search that correlates dwell time on the website also. Wish list. If the user add some items and remove again and again add, that behavior also the monitor and stores. So that code is an event generator. So whenever all the event generated that I'll talk about that goes to the feature store. So that comes the feature store pipeline in the convention. And the feature can be stored for offline purpose. Offline meaning here for training your models. Uh, like for example, user histories, item properties. What item property user looking into that? The real-time context. Real-time context means uh, what time user asked for that product, like seasonal, festival, particular time, what age groups, related to that, all the context in product context information. And user item interactions. User item interaction, which item user mostly buy, yeah, like. Finally, and create embedding and store the feature store. And that feature store used for training online feature store. So feature store is the big another topic, but feature store might be offline feature store for the training. Another is online feature store that would be used for your recommendation engine. And out then your uh, insight collector. Yeah, that time to need to generate candidate and that candidate pass to the ranking. So for generate the candidate means here items like list of items that need to be, yeah, suggested item need to be passed to the ranking model. Ranking output goes to the finally user. That all. So feature is like here is a numerical form, a number that can be stored and that can be used for further uses, for especially for content generations. It will use for ANN and will approximate nearest neighbor retrieval, and then ranking model. Ranking model output can be for another rule-based engine also, business re-ranking and personalized logic can be written for that. Yeah, so feature store we able to understand now, and now I'll talk about candidate generations layer. That is a very important layer, very important. But candidate generations layer will use whatever data available, yeah, online coming in the feature store. So data available. So whenever you, for example, just imagine you are on Amazon.com, buy some project, clicking on that history go to the feature store. Now Feature store या offline या online. Offline used for past learning, online used for current recommend. Anyway, both are used combinedly. Uh, so, and then candidate generator will create candidate. Like for example, you have millions of items in the list. Amazon has millions of items. Which item has to be recommended? So it will produce like top produce 500 to 200 candidate items, and it should be fast. That is the matter, because user don't want whenever you click and your recommendations engine recommend you the items. So this process should be finished in millisecond, 5 to 10 millisecond, like let's call it 10 to 30 millisecond. Whole things completely done in the few milliseconds itself. Correct? So that is content generation layer. Sorry, candidate generations layer. Okay, we will go one by one candidate generations layer. One is item to item collaborative filter. Another is user embedding that used for ANN retrieval. Third is content similarity. What the user asks directly. Description based on the description of the product. Popular and trending. So we'll talk about four content generation layer component. One by one we'll go. First we'll go about item to item collaborative filtering. Why we talk about here, this is a collaborative filtering. Item to item meaning here people who interacted with particular item and also liked what. I click on user. You click on a RoboCar toy. What else you like most? So based on that, like it will create like based on that. So we want to recommend that. That is called item to item collaborative filter. So why here collaborative meaning here? So for that offline how it will done? Offline it's compute co-occurrence. Co-occurrence like there are millions of users. Might some user purchase RoboCar along with sensor kit and motor pack? This example I will take. Some user purchase RoboCar sensor kit, RoboCar motor, motor sensor kit, blah blah blah. So these are pair co-occurrence pair created and store this embedding in the embedding store. And that embedding can be used for further whenever new user will come and search RoboCar, then it will fetch nearest neighbor, approximate nearest neighbor. So this way it create a item to item collaborative filtering. So millions of items it will filter, it will take 500, yeah, 1000 items. And out of 5,000 items, then we will rank using our ranking system. That would be next. Anyway, candidate layer output goes to the ranking. Candidate will generate like millions of items to 500, yeah, 1000 items. Next is embedding and retrieval. So we have embedding space. Embedding might be user embedding. Okay, so here user embedding very important. Previously talk about item to item, but here user embedding. So user embedding especially for personalized marketing. Let's say sorry, personalized product recommendation. We stored all user embedding, user interest, age, purchase history, likes history, view history, everything we stored, create embedding. So next time any user come to e-commerce platform, search some product. Then this user embedding triggered, it will give ANN retrieval means ANN search. Okay, this user give me top K 100 similar user what they purchase. So this kind of user purchase these items. Now what would be the most item that will go for ranking also. But how this user embedding work that I'm talking. The last is second last is content similarity. Content similarity here. Okay, you write on the e-commerce platform, I want a black color robot toy that can be built by my 8-year kid. So you put your age here, color, build means like it would be a learning toy. That feature you write. So that feature, so there again, this content similarity. Anyway, this all content embedding already stored in some vector DB. Okay, this content embedded related to these kind of product that have mapping already. So whenever you are search, create embedding and it will go to the similarity search. Then it will retrieve thousands of records that will go for ranking. So it would help for cold start. If your new item also new description, how you will start for selling that, how you recommend to user, okay, this is new product, I don't know where I have to start with this product because this product is completely new product, right? So then you how you recommend to user this product. So content similarity is very important for that. Even the new user also coming and they are writing something, you can recommend using the content similarity sparse data you have, right? So how this user content similarity working that I explained. So I recap it. Content similarity means user asks some using content that create a content text embedding. Text embedding you are doing a similarity search for text embedding, then it will give a similarity scores bed scored embedding list, item list, and might be it will suggest you new product also, so it will more trend to new products and users. That's all. Okay, we'll talk about this is very important, popular in trending means, oh, this is item is more trending now. What is hot right now, right? Trending means what is hot right now. Someone want to search some trading product, explore new product, right? And if a user will come, then how you highlight the product for personal users, right? So all things. So for this input would be click counts, purchases, if you have new users, how do you purchase something, and what are trending, velocity growths at all. And then you recommending that, okay, example, user searching, okay, I need this is the product and what is hot right now. So hot means hot related to, for example, you are searching what is hot right now related to toy, learning toys area. So then it will for my 6 to 8 grade student, so it will search that and then it will give you a trending list. So these are category I told that would be a current candidate generation layer. So all 4 category combined with one and then it will go for ranking. So all 4 method talk about that: collaborative filter, user embedding, content similarity, trending, and popularity. We'll get all embedding, mix it, then now we'll go to the rank. Then rankings. We don't know, like we don't know about user one trending, user one content, user like user similarity might personalized content, item collaborative filtering, like especially related to item. NN will give you personalization, content similarity will give you what you want to search it, trending it will give you what trending now, that might be so based on all it will give the list. Still we don't know what should be probable item to the content. Okay, we know this list of item, but what should be the probable item? Might be you are merging this all, might be you will get some duplicate, right? Then you just do some cleaning work and at all remove duplicate around near 500 to 1000 item you will get, right? And that need to be fit for ranking. So that question is coming in your mind now. I think that is why multiple generators. Okay, I just recap it. Collaborative filtering, item to item collaborative filtering. Item to item collaborative filtering, it will be contextual, like user to item, yeah, item to item. All the user embedding will give deep personalizations because we know the user your whatever history, basically wish list, lot of things you did with your e-commerce platform. Any if new product is there, new listing is there, new vendor is come, how is recommend, how suggest to new user, that is content similarity. Trending and popularity, I already freshness, what hot right now, that is the questions. Okay, so together if you do, then we will get strong recall, and because of each one strong, each one is good at for something. Okay, so this output 1000 of this item will give to the ranking now. And now I'll talk about the ranking, how ranking works for the enterprise scale. Okay, if you think about enterprise scale, then what is matter for you? Enterprise scale matter for you that one is latency is very important, right? Latency is very important. So whatever engine you are building, like content generations, you know, event triggering, Kafka, feature store, and then content generations, then this ranking. All should be finished in milliseconds, right? That's matter. That's matter based on your latency. You have to decide the tools here. Correct? So you will get content generation give you 500 to the stored possible items, and ranking decide top 10 to 15 actually can be used, right? So basic MID can be used. You can train that model also for this, especially a execute a deep learning model, a transport, whatever. So what would be the input for? Now I'll talk about how ranking will work. So any ranking engine need input. Input would be combination of all. Input would be a user signal, what he clicks. So what is inside in cart, dwell time for particular items, what are item already purchased, what are context. Contextual means like today is a festival day and user come on this festival day and he want to search something is really for festival, that is context. What is age, what is interest. Cross feature means like looking for, any discount game. So what purchased, what discount given, both embedding should be there in feature store, right? Cross features, most predictive features, that will come in cost features. So finally all thing will take as input and output will give you. Okay, the cross features would be a like a user embedding, the user purchase that item embedding. Cross features. Category affinity score. Category means particular. Okay, electronics category. What would the affinity is there for? This is the electronics product is searching for. What is the price gap actual versus this? All this like kind of I can say cross features can be taken as input. So we'll talk about input. Now we'll talk about will give this input to the ranking models. What kind of models used for enterprise scale? First is I will talk about that is popular use gradient descent, gradient boosted trees, or yeah, decision tree, XGBoost, GPTT. And why is popular? It can work for tabular features. Inference is very fast. In 1 to 5 milliseconds, you will get answer with this. And I will talk about wherever latency matter. Most of at scale also use decision tree, yeah, similar classical machine learning models for this prediction recommendations. Second is deep learning. Deep learning ringers that open source also use like wide and deep FM, yeah, DRLM, two-stage transformer. Lot of things can be used, but matter here latency. So might be for this kind of generation, back is running and it will give you, but latency is matter here. Another is multi-objective rankers. So not for internal, not for outside user itself. So these ranker will give you for purchase probability. Like okay, what is probability user purchase this item? Using this item, what recommendation, what expected revenue, what is user retention? Okay, user will come, yeah, for example in card, but definitely it will purchase. What is seller fairness? User why not coming? So a lot of things can be generate and get out like multi-objective rankers can be used. So output of this model will give you top K. Top K means thousands of candidate shrink with 5 to 10 candidate and show to the user. That is top K. So that is target, like how model is are trained. So these model first need to be trained based on like okay CTR, click through rate. Okay, these model, okay, click more. This CVR, which product most purchased, and which product most impact to the revenue. Based on that, they are trained and recommended to the model. So that model based on their train and recommended. I talk about another thing also, that is user to item collaborative filter. Okay, so uh, where that embedding can be used for, anyway, this is again content generation time, right? So I in this video we already like we discuss the component of recommendation engine. First is user come to the website, your app, then it will do something, then you went to trigger, then it will go to feature stores, then create candidates, 1,000 candidate, then it will go to ranking will give you top 500, and finally you will get the output. So how the recommendation engine work? Another recommendation is that I'm talking personalized content generation and personalized recommendation, where now the Gen AI used for attract the customer for particular products. Your 5 year, 10 year history, AI know that what you want to purchase. Based on that, it will generate content, image and video, and share with you WhatsApp, video, email. Yeah, whenever you open the page, it will show that image. Yeah, some ad for you, especially ad for you. That very you know amazing to seller, because it will attract to user. You, model AI know what you want. it will show you, it will break your thought, and you just click on buy and purchase it. That's done. That is job that ads want to achieve. So these all about how recommendation engine work for enterprises scale. Anything is missing, you want to more detail about it, okay, if any you needed how you can implement as a technology wise advice, so I will show in another videos also. If you need, then please comments on comment sections. Thank you so much for watching this video. Thank you so much.